On behalf of SICCI, this is the second edition of EVOKE presented by the SICCI EV committee. Just a quick note about SICCI. SICCI is a 111-year-old industry body which aids aids the industry in every possible way, and acts as an interface between the government and the industry bodies. And this EV committee is a forum that we started relatively recently, and EVOKE is one of our primary webinar series, and this is the second edition of it. The previous one was on the public awareness. This one is on the software and side of things. I now leave the stage to the experts who are good at it.
Sure, thank you, Danny. Thank you, everyone. I think we've have an amazing participation. I think there are like over 340 people in here. First off, welcome. So my name is Henry Joshua. So I'm the Advanced Services and Electrification Head at AVL. I'm sitting here in Germany, but happy to join you all virtually, at least virtually today. I just wanted to help set the stage to hear very interesting and amazing things that's prepared by Mr. Binoy Paul. I'll let him introduce himself. Before we get into the EE architecture and the software part of EV, EV seems to be a very interesting or a highly talked about topic these days. I mean, it's a very cliche statement, but it's a true statement that, you know, it's a rapid change. There's no other industry at the moment that's going through such a fundamental change other than auto industry. I mean, many things have changed, right? Like, I mean, from hydrocarbons to electrons. In the conventional engine, the powertrain components, there used to be 3,000 parts or components, and now we have 300. They have implications, both economically and maintenance and all of that. The simplicity by itself could be complex. And one important key point in context of today's conversation I want to say is software. Cars used to be software assisted. Software used to be a part of the car to help certain functionality, right? But now software is the center. Software actually helps to differentiate cars. So software is a very key part, and all of these are different from the conventional times. It's changed a little, in these areas. To support the softwares, though, while I would say the mechanical parts got reduced, the electronics increased. The number of sensors and the types of sensors also increased. To process those signals and to make decisions in split seconds, communicate to other devices, we need really fast and robust microchips. In the past, for example, like in the conventional combustion world, a premium car would have maybe around 150 ECUs, but I mean around 100 ECUs. But now in EV, we have even a normal regular car, not premium, but we are talking about regular cars. We have like around 150 to 170 ECUs. And these are like over 3,000 microchips. And these contribute, the electronics contribute to almost 40% of the vehicle's cost. Now, how these electronics are arranged and organized, that's where the topic of architecture and platforms comes in. I'm not sure the full background of all the participants, but just to set the stage, I want to introduce two words here. One is architecture, another one is platform. What is an architecture? An architecture describes the physical layout and how it works, like how the EV realizes its function. Say, for example, a hybrid electric vehicle could have an architecture with a combustion engine, with battery, with e-motor, and how they are organized, in what series, parallel, that's an architecture. And then there's also something called platform. The platform is the foundation on which the vehicles are based. These days, with electrification, the topic of both platform and architecture is important because we have to look at this from a ground-up change. With that, I want to hand over to Mr. Binoy Paul, and I would request to please make a short introduction. And we are waiting very eager to hear more about architecture. Just one last note before I leave. Architectures, not to get confused, there are two types. There's mechanical and electronics. Mechanical in simple terms is related to what happens to your chassis when you crash like this. And electronic architecture, let's hear what that's about from Mr. Binoy here. Thank you. It's all yours, Mr. Binoy.
Thank you, Joshua. Thank you, SICCI. This is always happy to be with the industry community to discuss topics of relevance. Um, I myself, let me introduce. I am leading the electrical, electronics, and software engineering topics in Mahindra, based out of Chennai. Even though Joshua is in Germany, he's online. I'm also online. I'm not in Chennai. We are all online. That's the beauty of the new world. I'm based out of Mahindra Research Valley. I have 25 plus years of experience in automotive industry. Almost always in electronic space, software. Started off as a software engineer in the automotive industry. Very excited to be part of this industry, as Joshua mentioned, the amount of change which you are doing, and happy to be part of the stream of engineering where all this is happening. So very glad to be here to talk about what the industry is doing from an OEM perspective. Now, one of the things which happening is just picking on from where Joshua left. One is the mechanical to electronics and software transformation from a pure engineering stream perspective. The other is the responsibilities of each of the organizations is also changed. The OEM's responsibility, the tier one's responsibility. The automotive industry is the first industry who started calling tier one, tier two, tier three. The other industries do follow that. Now that demarcation, it used to be very, very clearly laid out and aligned. What does tier one do? What does tier two do? What does OEM do? What does dealer principals do? A lot of that is blurring. The business models are changing. So this is also a churn which we are in, and all of these changes creates a lot of opportunities. And I know most of the participants here are, I am assuming most of the participants are in the early stages of their career. I'm sure I was told that there will be also students in the call. So I want to start off saying that this is an industry which is in a state of flux, in a state of growth, and so much of technologies which you hear is all coming together here. In multiple industries, a lot of technologies are being developed, but this is one part where a lot of things are coming together. Okay, we are talking about sensors, we are talking about autonomous systems, we are talking about robotics, we are talking about customer experience, we are talking about streaming video, we are talking about cloud computing, we're talking about AI algorithms, we are talking about machine learning. All of that is in automotive. So if you look at an industry where a lot of this new tech is getting presented, and end of the day also being used by the normal consumers, it's not a business to business industry, it's a business to consumer industry. So actually we are enabling a lot of these technologies to the consumer. So I'll start off with my presentation with that introduction. We as Mahindra is very proud to be in the forefront of bringing a lot of technologies to the market. We believe democratizing technology is probably one top perspective which we carry as the engineers in Mahindra. This picture which you see on the screen as a background is the new vehicle which we are working on. This is something which we are working on as we speak. This has been previewed mid of August this year, few months back in our design studio in UK. So this is something which is going to be coming in Indian market by 2024-25. As you can see, the amount of graphics, the amount of interfaces, the amount of electronics which is going into the cockpit, what we call the IP, the cockpit, and including some of the augmented reality displays which you see on the windscreen. That's the type of um, exponential growth which we see in electronics in the vehicle, which in turn is also software, right? So many of you in the call would know XUV700. XUV700 had a similar setup but with two screens, but no heads up. So there is an upgrade to that. I wouldn't call it an upgrade. It's a big evolution which is happening. Okay. So on what is happening in electronics architecture. So I want to go to this topic from a consumer angle. Why is these architectures evolving? Why is software becoming so important? End of the day, we are making in products. Electric vehicle is a market demand. Newer architecture is a market demand. When the consumer is expecting, the demanding consumers is expecting, based on that, the products evolve. That's how successful products emerge. It's not the other way around most of the time. There are cases where it becomes the other way around, that there is a pretty great product offering and then the customers align to it. But most of the time, products are created to satisfy a customer need. What is happening in automotive? In automotive world, we are just a minute. We are looking at a lot of innovations and a lot of differentiation. Uh, Automotive business is a very competitive business, so there's a lot of differentiation needed. And as we get into electric vehicle, as we get into newer technologies, there is also need for a total cost of ownership as well as a total revenue for the business. So these are some of the underlying aspects where the software becomes more important, and the customer expects the product to be very personalized. So there is this concept called n equal to 1. Okay, so you are a customer, your product, your car will look and feel very much yours, and your neighbor's car, even if he buys the same car from Mahindra, will look and feel very differently. So there's a lot of extreme customizations possible, and these are all possible predominantly if you do it on a software oriented architecture. Okay, so that's the evolution which is happening. And then also, after buying the car, you want to configure the car after buying the car, okay, not while buying it. That's also a soft. That's when you actually enable and disable some features. You have a set. A vehicle will behave in one way when you are going to the office on the 5 days a week. The weekends, the vehicle will behave differently. You know, those are the possibilities which are happening in the as we speak, and more in the future. Okay? And that creates revenue streams also post SOP. Okay, now this need of super customization, evolution, future proofing, and an extended what you see, what you use in the home, what you use in your mobile phone, you expect the same in the car, right? You want the car and the drive to be an extension of your lifestyle. Car is not no more used for just going from point A to point B. The car ownership experience is more than just going from point A to point B, right? So all of that comes together and create a need for evolution in architectures. Okay. This is a typical architecture which pretty much everybody have today. It's a domain-based multiple ECUs through a gateway architecture. The lines which you see is typically CAN interfaces, and these blue boxes which you see are each ECUs. So braking will have one ECU, instrument cluster will have an ECU, air conditioning controller will have one ECU, and all of them will talk over CAN, and we group it by domain, powertrain domain, chassis domain, multimedia domain, autonomous domain, and things like that. So this is what we have in Mahindra's perspective. Those two pictures you are aware of what they are. Those two cars have this architecture. That's what we have today. Okay. Okay. In the future, we are talking about a car to be more like a smart car, like a smart. What happened from a phone to smartphone? That is what we see happening in the car. Okay. Now there are different options and opportunities to do this. There is the way it is happening today is software is implemented in a monolithic way. So a software which is implemented for ABS will be one supplier. Surround view camera will be another supplier. There will be buckets of software implementation, and then the only common factor is the interfaces, messaging interfaces. Right now, what is the challenges with that? If you want to improve or if you have to update the software, then it becomes multiple ECUs, and then you have to ensure that all the ECUs talk to each other. With the new version of software, everything works together. Any change which you do, we have to do by domain, right? And all of that means a lot of cost in getting these changes done. And OTA, over the air updates, all of that is not very normal in mobile phone. It is still very nascent stages in automotive, mainly because of these complexities. It is not, there are not many vehicles today in the market globally where you can do an OTA for all the ECUs. There are OTAs in most of the vehicles, but that will be limited to few ECUs. There are vehicles which does that, but because of this architectural complexity, it becomes very, very difficult. Now, what can happen in the future, or what will happen in the future, is that softwares become more of a microservices, and then hardware become integrated. So this is led by the development of a lot of silicon technologies, like the controllers, SoCs, system on chips, have become much more complex and much more capable. So we today have automotive grade controllers which can go up to 500, 600 K DMIPS. Yeah, and that was completely unimaginable. So just for comparison purposes, the most of the ECUs which we have in the car, like an ABS ECU or a engine ECU and all that, it's around 10 K DMIPS. 10, 5, 6, 10 K DMIPS. Yeah, maybe 20 DMIPS max, K DMIPS max. And now there are possibilities that we can have a controller which goes up to 200 kDMIPS, 300 kDMIPS. kDMIPS is a measure of computation. Most of you will know that. So if you have that kind of facility in a silicon, then obviously there is an opportunity to integrate a lot of these functionalities to one controller, and then define functionalities by software, and then create functional microservices. And this is not a new concept. When people went into cloud, this is exactly what happened, right? When people migrated from on-prem to cloud, on-prem was all physical servers. When we moved that whole IT infrastructure to cloud, then we had a infinite compute available, right? Which is again server farms, but from a perspective of cloud, it was infinite compute. When it have infinite compute, you started having software-defined microservices. That's exactly what will happen in the vehicles, yeah, because of this compute in enhanced compute availability. Yeah, what helps here is that we'll get cross-domain functionalities. We can get very, very easy upgrades. Continuous deployments is possible because software can be flashed over there, and we can actually do multi-domain flashing, multi-domain integration, in one go. Yeah. And there will be and the other thing which is happening here is that the connectivity. Now, connected car was like in Indian, let us say in Indian perspective, 5 years back, there were not many cars which are connected, right? The first time we got some connectivity was when we have the public transport vehicles needed a call emergency button, right? That was the IoT starting, like in the automotive. Now today, if you look at it, again take our example, Mahindra, the XUV700, 100% of the vehicle which are sold are connected. Now that is a major shift in the level of connectivity which we are getting in the vehicle. from 0 to 100% in over 5 years, let's say. That's not happened in any other market. India is very unique in that case. And this is happening across the globe anyway, right? Especially when it comes to EV, connectivity becomes standard. Like even the two-wheelers is expected to have connectivity because fundamentally you have to start searching for an EV charging station. You want to have cloud connectivity. If you want to start doing some computation of battery management or range prediction, you could do more in the cloud. You don't need everything to be done in edge. So EV kind of triggers the need for connectivity. In that way, EV also triggers the need for more software. So it's not that, yes, everybody talks about when you go to EV, you have more software, more electronics. We have to understand it from a different perspective. If you think about it, EV is just another powertrain. Instead of an ICE engine, you put a battery and a motor. Yeah. But when you do that in a car, you will end up re-architecting it. And when you re-architect it, there is also this other perspective of semiconductor becoming cheaper. You have connectivity, and the domain blocks can be broken because it's a new architecture anyway. So that's an opportunity which has been grabbed, and that is how the software and electronics integration becomes much more intense in the EV world. Okay. Now there are multiple ways of doing this. Many OEMs are adopting many approaches. So as I said, almost all the OEMs were in a CAN-based gateway architecture. Some of them are going for a zonal, complete zonal architecture. Some of them are going for complete central compute. Some of them are doing partial zonalization. So I can't comment for other OEMs, but for Mahindra, in the current XUV700 and Scorpio N, I would call we have done a partial domain integration. So if you look at the infotainment instrument cluster and connectivity in the new Mahindra vehicles, it is all in one controller. So that's a domain integration. So it's a domain integration is the first step to go get into centralization, right? So that's a journey Mahindra is in. Okay. Similarly, multiple OEMs are doing the similar things, or at a very different levels of maturity and levels of integration. The ultimate integration is to have a central vehicle computer. Okay, and with zonals, that's the last picture, where the zonals are only for sensors, and there is a single compute which does all the computational tasks. That's the if 2 years back I would have said that's a holy grail, but today I know that this architecture is possible, so it's not really a holy grail, it's doable. It's the future, it's a near future, it's not a distant future, it's a near future, the central compute. Okay. This I'm talking from a global scale. Now we started calling these approaches central, zonal, and all, and adapting some naming conventions from a cloud perspective. Nowadays we call them high performance computes. So high performance computes are central compute systems which probably is at 100 kDMIPS or 50 60 kDMIPS plus, like very high performance computes, which runs typically Linux or an Android or a very high-end operating systems, adaptive AutoSAR and AutoSAR type systems. That's what we call high-performance compute. So then there are zonal controllers, which will be the typical microcontroller type architecture, which is for interfacing the smart sensors and things like that. And then those communicates over CAN-FD or Ethernet, which is another. So Ethernet has happened in the car. There are vehicles in the field today which has communication on Ethernet between multiple ECUs, and that is picking up a lot of speed. That the vehicles are connecting, the high performance computes are going to talk to each other through Ethernet. I think that is getting pretty much a standard across the globe, that if there is a high data bandwidth and between high performance computes, there will be definitely a lot of data to be transferred. Ethernet is becoming a de facto standard. Yeah. Now, there is a side effect of all this. There is a lot of reduction in wiring harness, which again reduces the weight. The number of ECUs reduces, which means that energy consumption sometimes comes down. I use sometimes because some of the high performance computers are actually very energy intense. But in overall scheme of things, the overall energy consumption comes down. And this is another very critical factor for EV. Every watt you reduce increases your range. Yeah, that's a very directly proportional description in EV. So which means uh, in the past, in automotive, our focus was on vehicle weight reduction. Right now, in the EV world, our focus across the industry is to reduce the energy consumption. How can we make the vehicle move more efficient? So reduce the CD, reduce the weight, reduce the energy consumption. So many of the lamps are going from halogen to LED. Many of the controllers are getting centralized. Um, Many of the motors, when I say motor, like wiper motor, everything goes into a little bit of BLDC type architecture so that you don't just waste your energy. So many aspects. The war on weight was a slogan we used to use in automotive. Now it's almost like war on energy, because every watt you reduce gets you a better range, right? And range anxiety is one of the biggest challenges any EV manufacturer is trying to solve. So again, within the high performance computes, if you call ABC, now this ABC, why the high performance computes are multiple is also there's a fundamental angle to it. There is a functional safety aspect to it. So some of you may have heard of this. There is a standard across the industry called ISO 26262, which defines what are the functionalities which are safety critical, which have to be redundant, which has to have error handling mechanisms, and there are features which are uh, even if that feature doesn't work, the vehicle will drive. There's no accident. Like if the music doesn't play, the car is not going to get into trouble. Whereas the brake issue doesn't work, you're going to be in trouble, right? So there's different levels of functional safety, and there are challenges in putting multiple levels of functional safety features in one box. Yeah, whatever be the software architecture maturity we talk about, there is nothing like hardware separation in many things. Okay, so this typically nowadays what happens is that this HPC 1, 2, 3 HPCs get defined by way of grouping by functional safety requirements, kind of drives this architecture. The software architectures are also available to create containerized solutions where you do different levels of functional safety containerized and then still run everything on one controller. We have multi-OS systems, hyper-V systems. We can run Android, QNX, Linux, everything in one chip. Having said that, as of today, as an industry, we are still relying on a lot of hardware separations to achieve a lot of these functional safety requirements. So that's one of the angles which defines the feature split. Again, multiple OEMs does it in different ways. So this picture shows different ways of the splitting of features. There are people who does infotainment, in-cabin sensing, parking, and ADAS in one ECU. That's the first row. And there are some OEMs who does parking ADAS and in-cabin sensing in one. There are some OEMs which does parking ADAS and powertrain in one. Right? There are different ways and means of combining these things, but combining is happening. Combining of domains are happening. How each domains are combined, many OEMs decide it in their own ways. Yeah. Any questions there? I hear something. Okay. I'll so similar. It's in a this is represented in a different. There are also architectures where there are two high performance compute, and then there is a central compute approach. Okay, but most of current vehicle architectures or evolving architectures, you will see three high performance computes, predominantly around the cockpit, autonomous, and other vehicle controls type grouping. Yeah. Now, all of this is about vehicle architecture and electronics. Now there is the software which has to run on it. And in the software world, we are talking about DevOps and DevSecOps, which is a new terminology. So agile is kind of hygiene now, getting agile methodologies based on ASPICE and safe agile models is a default in getting software development. And then We get into the DevOps, where we have a continuous integration, continuous delivery, and deployment on a very agile way. And then there is a security aspect to it while developing the software itself. It's not about software being designed for security. It's also the development methodologies is done in a way that the software is developed in a secure way. Because you need to remember, when you're doing DevOps, you're actually directly getting into the end vehicle after your continuous integration, continuous verification, and continuous deployment. Continuous deployment means you're deploying to the vehicle through an OTA, right? Which means your development process itself should have its enough checks and balances to ensure that the software is secure. Okay, so that's the evolving trend in the software development in the automotive world. Nothing, again, nothing new. This is exactly how a lot of the cloud native products are being developed. We are adapting to it, but automotive is much more hardened. The software development methodologies in automotive will be much more tough, much more hardened. I wouldn't call it tougher. Many more controls and checks and rules and balances, because it is it can create life-threatening situations because of any software issue. So there is a safety angle to this, which has to be a layer added on top of whatever we do. So even if you're doing a cloud development, even if you're developing a component in cloud for automotive, there is an automotive hardening required to those software. There is a lot of software which we leverage from the consumer space. When we leverage it, it has to be leveraged. It cannot be 100% taken and put. There are scenarios where you actually put it in automotive. That is when we get into sandboxing and containerization of software. Okay, all of this is happening. It's a very, very fast evolving stage, but the end result is automotive softwares are going to be much more safety critical and secure way of development compared to other consumer domains. Yeah. This is a software view. Software architectures are represented in many, many ways. And software industry is famous for making things a lot more complex for non-software people to understand. Okay, that's a common feedback I get in my industry. But the fact of the matter is that there is definitely enough level of complexities. We have less hardware complexity. We used to have 3,000 parts. We have 300 parts or 600 parts, whatever, you know. But when it comes to software, the software components have become much, much more. So even in electronics and electrical, the number of hardware suppliers are coming down, but the software component suppliers are going up. So you are actually having a lot more partners to develop software which runs on your platform or the hardware platform. Okay, these are much more cleaner view of how an overall vehicle software architecture look like, including the external interfaces, the cloud, the application software, the middleware, software middleware, the microservice architecture, and the hardware platform. So if you go from top to bottom, it starts from what are the devices the customer is having, like an app or a smartwatch or even the smart appliances. V2X brings you connect to the infrastructure, right? That's external to your vehicle. Then the interface is through cloud. So that's integral part of a vehicle software development today. So vehicle software, vehicles runs with cloud as a companion in many cases, yeah. And then the application, which is the most differentiating feature for a product. And then the software platforms, which will help you get you the microservice architecture, the frameworks, the AI algorithms, the OTA frameworks, and all that. And then all of that runs on a hardware platform, which I spent a little my time extra earlier. This is not only electronics and SOCs and all that. There's also a lot of sensors, displays, multiple modems. All of that comes in as a hardware platform. Electrical architecture, network topology. There's a huge activity needed on creating a right power management. There's also a lot of work needed in distribution of electrical distribution, which is the wiring harness. It's used to be only low voltage. Now with electric vehicle, it's also high voltage. So if you compare that to a human body, it's like we used to have the nervous system in electrical domain. Now we also have the cardiovascular system, which is the high voltage. Yeah. So last but not least, different companies adapt different ways of software maturity. All the automotive companies are trying to becoming a software company, or at least software oriented company. There are different levels of that. software as a core business is ultimate. No, maybe I can say Tesla is in that league because they are software first. They, uh, whereas a traditional OEMs were using software from somebody and then testing it and delivering. Now then they started buying software and integrating and giving to tier one to integrate or something. Then there are strategic partnership. Then there are OEMs who goes into partnership with software companies. Some of the popular names, global OEMs are tied up with many software companies to bring the new vehicles. So there's multiple levels of maturity or multiple levels of ownership OEMs are taking on software. This is also an evolving space, but as I showed the arrow, it's kind of moving towards software as a core business. Yeah. That's pretty much from my presentation. Hope I could communicate some ideas to all of you. I'm open to any questions if you have any.
First of all, thank you so much, Mr. Binoy. I think we have a few more minutes before we go. By the way, to everyone, if you have any questions, please do share. Either you can type in the chat, or if you're able to speak up, you can also do that. I mean, our goal is to share the knowledge and what we know from our industrial experience. It's such an amazing, exciting topics that's going on with EV. It's a revolution more than an evolution. So yeah, please feel free to ask the question. Yeah, if we are not able to, or if you think of the question later, you are also welcome to contact me or so through LinkedIn. I think our LinkedIn profiles was also made visible. If not, I would share it in the chat later. Binoy, a question for you. As we are going through these changes with the different architecture from the zonal to partial zonal to cloud, what are the main risks or challenges that, or the roadblocks that you see in achieving these transformations in architecture?
Okay. Technical roadblocks, I would say, is more on quality. Okay, as I mentioned in the presentation also, the software quality requirements in automotive is much higher. Okay, compared to any other, I wouldn't say any other industry, but most of the software intense industries compared to that in automotive, when you bring this, it becomes a lot more challenging. Okay, that's one aspect of it. There is also the other aspect of organizational transformation, right? You have to think about if it is a software defined product, like think about it this way. You have different architectures. You have been working with a microcontroller type supplier base. Now we are changing to a SOC based supplier base. Now the SOC supply base is typically who is working in mobile phone industry. Think about Qualcomm, think about Nvidia, think about no. So whereas an NXP or a Renesas was our traditional partners in automotive. Yeah. They were pure play automotive chip vendors. Today we are working with companies who are big in media, who also is doing automotive. Yeah. So there's a big difference in the way the type of partners we work with. Again, in cloud, the cloud world, the biggest business Amazon works on is not automotive.
Do you think like the semiconductor and the silicon industry will influence
No, it is an influence.
progress?
Yeah, it is an influence, right? Semi industry and the cloud industry are having a huge influence in automotive. But the point is, the automotive industry used to work with unique automotive focused suppliers. Now we are working with general suppliers who are also doing automotive, right? That's a
Also
big
a complete different mindset, right? I mean, I think the previous suppliers.
Yeah, previous days, if OEM calls up a supplier and he's so dependent upon you, they will do whatever you want. Yeah.
Not anymore.
So there's a big difference in the way the partnership ecosystem is totally different.
One more question. I'm not sure if someone is sharing their screen, but maybe you should.
Yeah, It will be good.
not do that. Ashwin, maybe you should manage this.
Yeah, it will be good if everybody else go on mute so that we can hear.
Ashwin, could you please make a general mute? Yeah. Okay, but in any case, during the course of the slides or the presentation, there was also one word which I wanted to touch upon and also bring that to everyone's focus: cybersecurity. As we switch more and more into electronics and software, there is this topic of data security and the cybersecurity. How do you see data protection and cybersecurity tie into the cloud business that Automotive is going into? And should an average Indian driver be sensitive to this or be concerned about this?
Everybody has to be concerned about it. Okay, now let us start with the basic hygiene of a cyber. I don't want to even call it cyber security, but let me put it as a cyber hygiene. When you connect your mobile phone or Bluetooth, your phone book downloads to the car. How many of you have deleted your phone book when you rent a car or when you got into a car and you connected and when you came out of the car? How many of you deleted your phone book which is downloaded into the car? These are fundamental, cyber hygienes which we all have to learn. Okay, we are living in a space where there's a lot of data which is getting shared. Yeah? And in the bigger scheme of things, when you get into cloud and when you have vehicle using a lot of cloud, cybersecurity, and data security is a big piece which we all focus on. So there are multiple strategies. When it comes to, there are cybersecurity audits, there are cybersecurity relevant design strategies which we adopt so that the customer data is protected as well as there is no penetration and no attacks happening, right? We do a lot of penetration testing, all of that, right? That is at a OEM level. But I would say as a user level also, we all have to start having a little bit of cyber hygiene in the way we share our data, right? And I think it's a combination of all of that. It cannot be just achieved by only the manufacturers and the supply base and the technology companies managing it. Each and every user of these devices also have to become much more conscious about it.
Thank you. Thank you. There's one question. Maybe we can try to address this. Thank you, Nirmal Raj Lewis. The question is, I'm a core mechanical engineer with 14 years of experience in an automotive area. He's planning to switch the career. What would you suggest and what would be the basic skills? I would let you go first and then I would add a couple of thoughts what I have observed globally and also what I think it could be relevant from the Indian market perspective. But please, do you have some thoughts, Mr. Binoy?
I will start with a general comment that the most of the smart engineers I've met are all mechanical engineers. So Nirmal, you are in the good league. Yeah, I'm not a mechanical engineer to start with. I studied electrical electronics, but to me, I will only make this learning continuously new technologies is a necessary. It's not a skill; it's a mandate. Okay. And I tell this to many of my team members and the younger engineers. The technologies of today have a half-life of 2 to 3 years. Every technology which you're working on today is not relevant after 6 years. That's the industry we are in. That is the way the technology is progressing. Now, you studied mechanical engineer 14 years back, doesn't mean that you cannot learn anything new. You have to learn everything is new anyway. I studied electrical engineer. When I studied electrical engineering, there was no battery. Lithium-ion battery was not there when I studied electrical engineering. Okay, so don't get stuck up with what you studied in your college for 4 years. That 4 years is a fun platform where you started becoming an engineer. Then you have to continuously evolve as a person. As the industry evolves, you also have to evolve as a person along with it. So you attending these seminars is a good sign. You're trying to learn. So keep learning, find the right skill set which is aligned to your way of working. I see that you are already in a product planning job. Product planning is a a production planning, and is not a mechanical engineering job anyway. Yeah, you're in a production planning job already means that you already evolved, beyond the 4 years of studies. Yeah.
Mhm.
So that would be my feedback. Everybody has to learn. There is no way you are guaranteed that the 4 years of engineering will take you through the 25 years of your career.
Yeah, yeah, absolutely. It's a very wise words. I mean, we all learn every day, and there's no other choice. A couple of things that I could maybe add to Mr. Binoy here. To start with, electrical vehicle does not equal to electrical engineering alone. It's a combination. There is no domain, there is no product these days. Um, there's nothing that I would say it's only in one domain. I mean, you think of an electric car, we still have to design. If you think from a mechanical perspective, we still need design engineers. We still need packaging. We still need manufacturing of these battery. So in general sense, I wouldn't say mechanical engineering is not related to electrification. It's already very closely tied to electric cars. Second, um, I mean, as I mentioned, the EV is a combination of mechanical, electrical, electronics, and software in general, when I say that. When we speak of production planning, what I would recommend, I mean, first things that come to my mind, very close related to your existing experience. Of course, you have to learn new things. Think of, try to understand, try to learn production of the different powertrain components, because there is a specific production methodology and also assembly methodology of batteries. Let's take an example of battery. The same thing I can say about motors productions or so. So I think to start with, pick one of the powertrain components or even the entire chassis or so, and try to understand. There's plenty of information available online. If not, you're welcome to contact me on LinkedIn. There are resources where you can try to understand what is the production process of the battery, for example. How is the assembly going on? So if you start from there, I think you will find an overlapping area where you could bring your existing experience, but apply that to the electrification or the EV car process. So I don't see this completely disconnected, but there will definitely be learning experience, but that's what makes it exciting, right? So yeah, that's probably what I would add to what you asked.
So I have, I mean, like a friend of mine has asked the question and he sent me personally in my inbox. So I'll read that out for you. And this is also a topic that gets me interested as well. I mean, Mahindra are the top team in a Formula E race. What expertise and what kind of data do they bring in the regular road vehicles?
That's a good one. So I can't disclose too much, but the new platform which we are developing, which we announced, the BEVs which we are working on, we internally also call it race to road. Okay, so the racing program which we've been having, electric car racing, has given us a lot of insights. Okay, and all of that insights will go into our design. I can't tell more than that. Yeah.
Yes, sir.
Yeah, it is definitely part of. There is an advantage. There's a learning curve which we go through. That is how automotive industry works, right? The racing programs helps you a lot in um, in taking some decisions, yeah, in the design phase to create a better car.
And it's an amazing possibility that you have with the EV. I mean, there's no story where you can drive a combustion engine, a diesel car backwards and then be able to generate diesel in your tank, right? I mean, you cannot create that. But then with EV, we have these possibilities. Yeah, I think, and these are also reducing the overall cost of ownership. So when you use technologies like regenerative braking, it reduces the wear and tear on your mechanical braking. But then you also have, when you combine the mechanical braking with the regenerative braking, you reduce the wear and tear. There are statistics and there are information studies that shows about 40% of total cost of ownership is less for an electric vehicle compared to its equivalent diesel or a petrol car. Yeah. Any other questions, please? I mean, you feel free to share, and we will try our best to answer. If not, I think then we can also close our session. Let's give a few more seconds, and if we don't have additional questions, then I would thank everyone, and then we could close this session.
All right, I guess
Yeah.
that's pretty good.
Yeah.
Thank you. Thank you for the question listening.
Yeah, and I thank you, Mr. Binoy. Thank you so much for taking your time and sharing open knowledge and open source knowledge, right? So this is a good thing. Also, thanks to SICCI for contacting us and helping us. I mean, sharing knowledge is also personal passion for us, what we learn. I see there's so much of energy and motivation in India and the startups, and the ideas and creativity that comes out is amazing. So I wish everyone the best, and soon you will hear us with the next topic, or at least I hope SICCI will bring in the next topic with EV. And yeah, thank you everyone for participating, and have a nice rest of the day. Take care. Bye-bye.
Thank you. Bye.
Thank you all.